Welcome to another Todd's
2-Minute Tech Tip Tuesday.
brought to you by the National RV Training Academy, the largest hands-on RV training academy in America. Hey, Todd here. We're going to go ahead and cover the auto detect with WFCO. Now, did a couple videos on this, and of course we had some feedback left and right on how we were actually testing this. So WFCO reached out to us directly and went ahead and sent out one of their techs. So here I have Derrick with WFCO, and we're going to go over this auto detect feature. We're going to sit here with the Big Beard battery. He's going to prove to us that this will actually auto detect. So let's go ahead and just jump in here, Derrick. So I guess the whole premise of, the Tech Tip Tuesday on this particular video, Tech Tip Tuesday, whichever, is that you guys have an auto detect feature with your converter, which means the converter itself can either charge a lead acid battery, LA, or lithium battery, LI. Some models out there, some other brands, some previous models that you guys had was a little switch, but that was really up to the consumer to know what to do.
Correct.
So you guys then built an auto detect feature. So go ahead and talk a little bit about that. What was the mindset behind that? What were you trying to accomplish with that? And then let's get into some of the confusion out there on the auto detect feature.
Absolutely. Thank you. The reason we wanted to get away from the switch product that Todd was talking about is because that gives the end user the ability to manually put it in the wrong position. So you give somebody a button, they're going to touch it. I'm that type of guy.
Got you.
What we have here is auto detect. And one thing to make sure people understand is it's auto detect, not instant detect. It is not something you can touch the battery, and this knows what that battery is. What this does... Yeah, and that's what a lot of people don't understand. What this does, this has to read how this battery charges. It's either going to charge in a sloping curve like lead acid typically discharges, or lithium where it kind of goes in a flat line and just drops off to nothing. So this reads how a battery charges. So you guys, the end user, you need to have your battery the very first time discharge. Once we plug this converter in, it's going to start measuring how that battery charges, and it's going to auto detect at the end of that charge, because at the end of the charge, this converter is going to recognize how that battery charged, and it's either going to be in a sloping curve like lead acid or a flat line and then nothing, as your lithium batteries typically are going to do. So that's the basis of why we went to auto detect, how it has the ability to detect, but you guys need to give it a chance to detect by charging this battery, not for a little bit, but for a whole charge cycle. You need to let this charge this battery till it's completely full.
Yeah. So inside all lithium batteries, if they're worth anything, there's what's called a BMS, the battery management system. And what we do with the battery management system is we put the voltage limit on each cell, say 3.65. So as the converter is doing the charge, those individual cells, the voltage kind of reaches a maximum. Well, once that maximum hits, the BMS will open up a relay and just simply stop the charge. And that's what it's reading is does it slope off? In other words, do my volts and amps just kind of wane down, or my volts go up and my amps go down? Or does it just simply charge and then cut off? And that's what we typically see with lithium. So it's reading what the BMS is doing. Okay.
Correct. Yeah, that's a good way of putting it.
Okay.
Thank you. Yeah, that's actually very good.
And so from there, that's where the confusion is, because when we have these, like, okay, is it reading current? We find out not necessarily reading current. It's looking at the end of the charge cycle. All right, so there we go. We got the BMS inside. We do have it set for 3.65, but we're going to show you inside each converter, we have the lights.
We do have some LEDs inside the
converter. Some LED lights to kind of help you as the individual to verify whether it's in LA or LI, lithium or whatnot. Now, tell them why we can't really just look at the voltage here as we're charging.
Because what you guys are going to experience, and I hope you're referring to the voltage drop that these customers might encounter.
Well, just say, so if I just come over here with my multimeter and I'm looking, if this is being charged, I'm looking for 14 volts. I'm not going to see 14 volts.
You're not going to see 14 volts at the beginning because amperage and voltage are relative to each other. I like to tell people to consider them on a teeter-totter. When one's high, usually the other's low. So you're not going to read the higher 14.6 voltage when this is in lithium until about the end of the charging of this battery, because your amperage is dropping, voltage comes up. So you just got to remember, amperage and voltage are on a teeter-totter together. When you have a lot of amperage, my 55 amp converter putting 55 amps into this battery, you're not going to read 14.6. Your voltage is going to be lower. So just remember, one up, the other down.
So let's look at it this way. You have a water hose, and let's say it's got the little sprayer on there. When you let go of the sprayer, in other words, no water's going, you can feel the pressure inside the water hose. It's solid, right? Because there's no flow. Well, that's pressure. Well, that would be increased pressure. But as soon as you go ahead and press on that sprayer and you got water going, you can actually feel the pressure on the outside of that water hose kind of drop a little because you have flow. And so what it's saying is we're not going to see the 14 volts here if we're charging, because of course we're charging and all the amps are flowing through and they're not creating the pressure. So not until at the end, whenever we have little flow or no flow, that's when the voltage increases. So we can't, hey guys, don't have 14 volts. So we have to go all the way through. All right, so what we're going to do is go ahead and conduct a test. We're going to plug it in, and my BMS, we're going to be able to check the amperage. Now, this is a WFCO 50 amp model, correct? So we should see roughly around 50 amps when we first plug it in, as it's identifying.
Correct.
As long as my battery is sufficiently discharged, and we got it down to 49%. So what we're doing is we're recording the screen grab on the BMS inside right now. And right now we're currently sitting at 0 amps because this is not on. So let's go ahead and plug it in. A couple things that we'll see. You're going to see a spike. There's amperage going up. First off, you'll see the voltage kind of sitting around the same 13.5 volts, but we're sitting around 50 amps. And as long as the battery can take that, it's going to give it. Now, this is also part of the thought. Your converter is also connected to the RV, right? And if you have loads, say fans and whatnot, you may not see the 50 amps coming to the battery because it's also taking care of the loads. It's
Correct.
going to be shared.
Correct.
So
your converter, technically, its main goal and primary focus is the RV. Your battery is going to be secondary, so limit your loads in the RV to increase the amperage available for your battery if that's the case in your particular coach.
So right now, what we're confirming is we are charging at 50 amps. And on this 300 amp hour battery, it'd take, 6 hours if it was completely dead. We put that on a lead acid battery, you're still looking at between 8 and 12 because of the slope. We still have 13.61 volts, right? And we're going to see that until this amperage begins to cut off. And then we'll see the voltage drop up or shoot up. All right. Now, we've already confirmed that this is in lithium mode. Tell them, what are we looking for? If they could get to the converter and actually see it, what are they looking for?
So what you're going to looking for, we have LEDs inside our converters. Obviously, the deck mount's going to be a little bit harder to see because we got a metal box. But if you look through the fan vents, you will be able to see the lights glowing on the inside of the case. We have 3 LEDs in there that you're going to be wanting to look for. We got green LED, that is indication of lead acid mode. There's a blue LED indicating you're in lithium mode. Right now we're in lithium mode. We have a blue LED on in here. After about 30 to 45 seconds, when your battery is discharged, the converter is going to recognize that and it's going to throw a red LED on as well, which our red LED is on right now because we are starting to climb our voltage just a little bit and we're pumping in 55 to 56 amps. So we actually did just boost our voltage. Yeah. So right now we have a blue and a red LED on right at this moment, and that means we are in lithium bulk mode. So we are technically at 14.6 volts, but at 56 amps, you're not going to get that voltage reading. So we are there, but you're not going to see that till the end of that charge cycle. If we're in lead acid mode, you'd have a red LED join that green LED. That would mean you're in lead acid charge or bulk mode. What that means is you're going to go to 14.4 volts. So 14.4 doesn't just quite get there like 14.6 for most lithium batteries, but there are some lithium batteries that will actually do well with 14.4.
Yeah, and you really want that, right? 14.6, you're charging that battery up to 100%. Anything you do at 100%, you're going to limit the life, okay? Now, am I saying that, a lithium battery won't last 10 years at 14.6 if you charge it up? No, I'm not saying that, but if you can limit that charge, say to 14.4, right, and just give that battery a little bit of breathing room, right, you're going to see far more cycles out of it. You may get well beyond the 10 years. And so like on mine, that's part of the programming that we do is I'll go ahead and set it to 14.6, but we tell people to set their charge parameters to 14.4, right? Now, the reason that we were, with earlier batteries and some of the lower end batteries out there, the reason why you got to get to 14.6 This is what's called passive balancing. There's 4 cells inside, And each cell could be just a little bit off over time. You know, you're charging it, you're discharging it, charging it, and discharging it. You got internal resistance in each battery, each cell. Don't worry about that. But over time, it'll get out of balance. Well, you had to charge them up to 14.6 because you had what's called passive balancing. And so there had to be no current coming through, and then slowly the BMS with a millivolt charge would charge it back up. And that may take a month. Some of the newer ones, the reason why we built ours is because we put in active balancing, which allows it to balance at a lot lower voltage. I got it set to 13.8 volts. I could change it to anything. So with that being said, we can literally 14.4. Yes, we may only get 270 amp hours out of a 300 amp hour battery, but at least the battery itself, all the cells are balanced and you are not hurting that battery. You're not running it 100%. So guess what? It's going to last a lot longer.
Absolutely. I try to compare it to people that keep their phone plugged in all the time. You don't want to keep your phone plugged in all the time because you're going to go out fishing or whatever you do, and you're going to realize that battery and your phone's going to die a lot quicker than somebody that plugs their phone in when they need it and then unplugs it as soon as it's charged. That's kind of the reason our converter is a multi-stage charger. When this battery's fully charged, it's going to recognize that it's fully charged and it's going to drop its voltage. We're not going to stay at 14.6.
No.
His battery doesn't want that. Neither does, I don't believe, any battery on the market.
No.
So we will drop our voltage down. That's safe for the battery and your
I'll
RV.
drop it to roughly
13.6, 13.7-ish, right around there.
Yeah, so as soon as, and this is the way a lot of people still understand with lithium, we charge it to 14.6, but as soon as you take away that charge, you have what's called a resting voltage, right? So when we're being charged, we're at 14.6, but it'll rest between 13.2 and 13.6. You know, you may have some head pressure there for a little bit, but let it sit there for a day or two. You'll come back, this battery is resting in the 13 range, and that's what you really want. Just kind of keep that float mode. Derrick, I appreciate you and WFCO coming out and actually going over this. Now, there's going to be a few instances, though, based on the design of the RV where, you know, maybe some of the earlier versions like this may not work. Let's without talking brands, how do we go over that?
Correct. And this is not trying to throw any OEM under the bus. The RV industry was not ready for lithium. The batteries and the knowledge is there. It's just the RVs are not being built to what this battery wants.
Right.
So what we find a lot is the converter may actually be a lot further away than what we have right here on our tabletop. Tabletop, this is working flawlessly. I mean, this is perfect. But your converter might be 20 plus feet away. It might be a little bit more, a little bit less. But what happens when we do that is called voltage drop. So the converter voltage coming out of my converter might not be the voltage getting to your battery. We're losing voltage over distance and gauge of wire, connections. Many things factor into that. That could lead to some issues with any charger. Voltage drop is not product specific. It's going to affect any charging source out there.
Right.
But what happens is that might affect the way auto detect detects, because it might make this battery look a little bit different at the end of the charge than what we have going on here.
So let's say we had a lead acid battery, and let's say we lost power, something like that, or we had a voltage drop. That may see that and, you know, identify it as a lithium battery at first.
On some of our older models.
That's older models, it may switch over. Another one is we're talking about maybe having the power source too far away. You're going to have that voltage drop because you have those cables are too long. They weren't really designed, you know, for the right spec, you know, to go 30 foot. They just threw in some cabling, right? Probably too small, just to be honest.
Yeah.
So you're going to have some resistance, which creates a voltage drop. That may fool it, but only for one cycle. And then it goes, oh, whoa, you're not doing what you did before. So
every time we plug in, it's thinking. So every time it's able to reevaluate what's going on. So if it were to revert back to a different mode, the next time you plug in, it can go back into the right mode. It just could be something made it look different than it should be.
So again, to say a lead acid battery, let's say you lose shore power. Well, it's going to read that drop, boom,
Correct.
to the battery, and it's going to go, oh, it's lithium. You plug it back in, it's going to start charging at the lithium rate, you know, and then once it sees that it tails off, it's going, oh, wait a minute, it's not lithium, it's lead acid.
Correct. It's thinking every time, so it can revert back to the proper profile. So that's the nice thing, is every time you plug in, it's constantly thinking again for what's going on now, not what it was before.
Okay, so again, it all depends on, you know, when you're looking at this, you may see something. So we really can't identify voltage or even amperage although my amperage is still way above even what it's rated, which is awesome, right? Just charges it that much faster. You know, wire distance, you know, proper size, everything else, we give it all it, you know, it can take. But as we're saying before, for technicians, inspectors, anything else out there, whenever we're checking this, if there is a reason why it's in green, it could have been just that one shot, right?
Correct.
So just gotta, we can go over there, but flip the breaker or whatever, reset it, put it back in lithium mode if it's a lithium battery, see if we have our blue light and say, okay, you know, if we want to speed up the process, right, to get it back over there.
One thing I want to stress about the LEDs, we put ourselves in a corner saying, hey, green is lead acid, blue is lithium. Again, we're talking about 0.02 millivolts of difference. 14.4 on lead acid, 14.6 on lithium. 14.4 is actually good for a lot of batteries.
Yeah.
So if your converter is in lead acid mode, it's putting out 14.4 in its bulk charge. So you're actually getting the charge that those batteries want. So don't let the lights fool you or make you think, hey, I'm not in the right mode. Maybe that battery likes 14.4. Maybe that's the reason it's staying in. It's just the way your coach is built might be preventing it from looking in a different way.
Right. And so it's still going to push whatever that battery can handle.
Correct.
Because one of the questions is, well, if it's in lead acid mode, does that slow down the amperage?
No. Even in lead acid mode, it would still put out probably
That
the same 50,
when we first
56
put
amps.
this up, you know, the older version starts off in lead acid, but
Yep.
we were still pushing 50 amps, right? He forced it into lithium by disconnecting it, plugging it in. What we did is, you know, he told the system, hey, we're charging, and then cut power. Boom. It identifies that drop off as a lithium battery. So we plugged it back in, straight to blue, still got the same 50 amps. So it doesn't even if it's green, it doesn't lower the amperage, so it doesn't take longer to charge up. Still going to go at whatever maximum capacity that converter can do. You just got a green light, blue light, or as you're saying, 14.6 or 14.4.
Correct.
Well, Derrick, I appreciate you coming out and going over the information with us. We just got to clear up some of the concepts of what's going on out here. So I appreciate you and WFCO for coming out here, talking about your product. Guys, it's working. Now, again, if you have a system set up, let's say there is a build out there, no brands, where maybe, you know, the power source is too far away. What can they do?
There's only a couple things that you can do. Obviously, one is beef up your wiring going from your converter to your battery.
We know
Sometimes,
how simple that is.
yeah, and that's not an easy task, and that's probably going to cost you personal money. Like, the OEMs are not going to pay for you to get new wiring in your coach. Let's be honest. The second is you can shorten the distance. The nice thing about lithium is those can go inside your RV. They don't have to be in a vented compartment like your lead acid batteries. But if that's not possible, one thing I told you earlier is I would recommend customers, if you're dealing with a very large amount of voltage drop, meaning the voltage coming out of your converter is not getting to your battery, which is going to equal in low amperage charging your battery, what I would recommend is installing a deck mount converter closer to your battery. Even though you have a power center, I would just disable the converter that's in there. Use your power center to hold your breakers and fuses. Install a deck mount converter closer to your battery to give you the charge that you are actually looking for, because the converter cannot make up for that voltage drop. It's up to you to either boost your wires, shorten the distance, or relocate a converter closer to get that voltage to your battery.
Now, one thing you told me, which we didn't cover yet, is let's say they have solar panels with a little solar controller. How does that affect what's going on here?
So what that does is you have two charging sources going to one battery. The battery is going to take the highest voltage. When it comes to battery charging, highest voltage wins. So what's going to happen is your solar panels and controllers typically are going to have a higher voltage than my converter.
Correct. A lithium profile or something like that.
And usually the distance is shorter, just like the voltage drop we talked about. But say your solar controller is putting higher voltage to this battery. The battery is actually going to take the solar controller as the main charging source of the battery. What that's going to do is limit the amperage coming out of my converter due to the lower voltage. And so what we have,
like it's a slope.
So what we have is it extends the time that my converter takes to charge this battery, making it the slope like you're talking about. And that can make a lithium battery look like a lead acid battery due to the elongated time of charging with two different
But let's
chargers.
go ahead and talk about that with that need. You know, does that hurt a lithium battery? Let's say this is in lead acid mode, charging to 14.4. We've already discussed that really wouldn't hurt it. But if they have solar panels, that's their top off in the first place. And it all depends on what your solar controller is set at. If you have it set to 14.4, neither one of them are going to charge to 14.6
Correct.
in that case. If your solar controller is charged to 14.6, this may still adapt back down to, say, lead acid 14.4, and then the solar controller will top that off.
Correct. And that's why I said WFCO, we really put ourselves in a corner just saying green lead acid, blue lithium. Really, both of them have a lithium charging voltage that it can get to, 14.4
Right.
or 14.6. We just kind of made it black or white, green or blue, lithium or lead acid. And really, in the case of your battery, it might not matter whether it's in green or blue, but there are some factors that people might see, hey, it's back in green mode, and that could be due to the voltage drop or the two charging sources battling one battery, because what happens is it extends the charging time that this converter takes to charge the battery back, making it look like a lead acid. So the coach has a lot to do with how this battery charges.
So we'll say this: we can't address all the different variables out there that would cause a problem like this. Sometimes, yeah, with anything, there may be a bad unit, but that's an exception to the rule. But there's a lot of variables when it comes to RVs, right? Again, solar panels, distance that we have, did you lose shore power or not? You're going to have those different variables that switch this. But rest assured, the way this works is whether it's not that cycle or the next cycle, eventually it should find it, switch it back in.
Correct.
All right, and another thing, let's say there is something going on, or you're just still having questions, right? The one thing I'd always say is stop going over to Facebook for your answers, because of course you're going to get everyone who thinks they're what I call a Facebook engineer that may have some knowledge or something. WFCO. Whenever I first did this, I didn't get the numbers I wanted. What I do, I called them. They answered the phone, right? There was no message or anything else. Not only that, but after they answered the phone, heck, they show up. So if someone has some questions, what should they do?
Oh, absolutely. Call our tech line, 574-294-8997.
That's his cell phone, by the way.
I give that out to everyone. But we do have techs that are working on product that will answer your phone call, and they're not just there answering phone calls. Anyone that you talk to at our tech support line is actually a tech that works on product. So it's nice. We don't have a phone center, so we can identify if you do have a problem. But a lot of times people think they have a problem when there's not really a problem. Again, we're talking about 14.4 on lead acid and 14.6 on lithium. So I think we put ourselves in this problem where people think there's a problem, but really 14.4, even if you're in lead acid mode, that battery's going to charge up like it should. So that's something we're still trying to figure out. But I think the best thing to do is call us and let's see what's going on in your coach. Do you have a problem with voltage drop? Do you understand multiple charging sources going to one battery and these charging sources don't talk to each other? Is that making things identify as something that they might not be? So, I mean, there's just a lot of unknowns.
Yeah, there's always variables out there.
WFCO, when we came out with Auto Detect, we did make a product that works. It works. We just showed you that it works. This is the original product that we came out with.
I got product number one.
Product number one. That's the first one ever produced on Earth.
Yeah.
Maybe not the first one, but
Right.
It is the original. It's the original firmware that we produce. Well, over time, we have learned a little bit more that your install of our product might not allow our product to work the proper way.
It works good on the table, but when you start all the different variables out there, different OEMs, different floor plans, everything else, you get new information like, oh, crud, we got to overcome those difficulties.
Correct. And so what happened is we had this waterfall effect of people going to forums or Facebook, and they're reading information from people that are not educated themselves. Instead of calling us, you saw the comments of, hey, Auto Detect doesn't work, or I'm not getting the voltage that you claimed, or I'm not in lithium mode. If you would have called us, we would have understood your frustration. We would have identified the problem. And with that problem, we could say, hey, you know what? It's working the way it should. Or you know what? You have one of our original firmwares. We think it might be best if you send it in to us to get an updated firmware to combat some of those environmental issues that stemmed from the way your coach might have your converter battery installed. So it's a learning curve, but we do have solutions. It's just, you got to come to the source to figure out how to fix the problem. So what we're talking about is the problems that might be encountered in your RV with the voltage drop or solar, multiple charging sources. That's present in all converters out there. It's just You might not have LED indicating that, hey, I'm not in the right charging mode. Just so happens WFCO does have LEDs. Your other products probably aren't going to have an LED indicating what mode you're in, whether it's doing the right thing or not. You're just trusting that it's doing the right thing. We just have a visual reference of, hey, lead acid or lithium mode, which is a good, but also something that might confuse you. So
Yeah. Here's the thing, guys. Here's a takeaway. Don't go to the forums. Don't go to Facebook or anything else like that. That's not where to go. Go to the manufacturer, right? Or Tech Tip Tuesday. And there's your tech tip. All right, before you get to the bloopers, which is why you're here in the first place, the RV industry needs thousands of RV technicians and inspectors, and now is the perfect time to do that. If you want to make more money or have more control over your time, go ahead and click the link below. Or if you just want to learn how to fix your own RV, got something for you there. Head over to rvtechcourse.com and get started today. Now for the reasons that you're out there in the video, roll the bloopers. Hey, Todd Hinson here, and I am with... Nope, I'm not even going to say that. Let's start over.
number 2.
Yeah. Anybody at rest.
Me
It's
too.
Stay at rest.
Same. Yeah.
Let me check that out. I was wondering how that would work.
I just learned something today.
No. Hey, next week's Tech Tip Tuesday, how to use your freaking phone.
I'll be watching that one, Mike.
No doubt. I'll be over here. That might take longer than 2 minutes. Show me what I'm doing.